All right, so today we're going to go through combining functions. So there's different ways to combine functions. You know, when I take two numbers and combine them together, think of math, we use math operations. For example, I have 2 plus 3, right? We know that 2 plus 3 is 5. Well, just like that, we can combine functions. And you can combine them by adding, we can subtract them, multiply, divide. Really those four operations that we've already done with numbers, you've already done with numbers themselves, but we're going to do them now with functions. And then there's one other type of combining functions, and that is using compositions of functions, and we'll get to that here in just a second. So if you look down here, it says define the function f plus g. So really what it's asking us to do is what is f plus g of x? What that really means, really simply, is just to take f of x plus g of x. It just wants to take two functions and add it together. So if I look up there, let's start right here. If I want to do, if you look at f, it's defined with those 3 coordinates. G is defined with those 4 coordinates. When I go to combine them, I can only combine them if they have the same input, if they have the same domain. So for example, do a different color here. If you look at this, I have 2, 4 and 2, 3. Those two have the same domain. So if I were to plug 2 in, right, I would go f of 2 plus g of 2. Well, we know f of 2, when I plug 2 in, I get 4 back out. When I plug 2 into g, I get 3 back out. So f of 2 plus g of 2 is equal to 7. So if I'm writing that new function, f plus g of x, I know that, right? If I put in 2, I got 7 back out. And the way I got that, right, is I took what f of 2 was, which is 4. I took what g of 2 was, which is 3. I added them together and got 2, 7. Okay, let's pick another place where they have the same domain there. So if you look at it, let's do f plus f of 3 plus g of 3. Right, so if you look up here at f of 3, right, they're right here and right here. If I plug 3 into f, I get 7 back out. I plug 3 into g, I get 5 back out. I add them together, I get 12. So here's another coordinate. I know that if I plug 3 in, f plus g of 3, I got 12 back out. Okay, last one. If you look at it, we've got this. We've got 4, 5, and 4, 2. So if I want to find what is f plus g of 4, right, that just means to take f of 4 plus g of 4 and add them together. Well, f of 4, right, I plug 4 in, I get 5 back out. If I plug 4 into g, I get 2 back out. I add them together, so f plus g of 4 is equal to 7. So I come up here, I plug 4 in, I got 7 back out. Now, one thing I want you to notice is if you look at, if I put 1, if I try doing this, f plus g of 1, I run into a problem, right? Because I'm going to go f of 1 plus g of 1. Well, g of 1 isn't a problem, right? If I plug 1 in, I get 0 back out. But right here, I have a problem. There is nowhere in f that has it does not have the domain of 1. Like 1 is not part of its domain, and so you can't evaluate that. You can't do that part, so that doesn't work. So when you go to when you add two functions together, really all you're doing is you're taking what the first function is plus what the second function is. But to do that, their domain, you can only do that when their domain, when they have the same domain, right? When they both had 2 in the domain, they both had 3 in the domain, they both had 4 in the domain. So it's defined for those 3 values, but not for the others. So that's a really important concept. When you add, subtract, multiply, divide these functions, they have to have, you can only evaluate them for numbers that are in both domains, okay, that are in both of them. Okay, let me erase that. Let's go to the next one. So next one is h plus s, and this is a little bit different because f and g were defined by sets of points, right? H and s are not defined by sets of points. They are defined by equations. right? H of x equals, you take the input x squared plus 3 and add 3 to it. S, you take 2 times the input plus 1, and you get your answer there. So again, h plus s really just means to say, what is h plus s of x? So what that really means, what we just said, that really means to take what h of x is, and we're going to add what s of x is. So in this case, because we have the equations, we could actually just add the equations together. So h of x is x squared plus 3, and s of x is 2x plus 1. So if I add them together, I get h plus s of x is equal to, let's see, I can combine what, the 3 and the 1. So I have x squared plus 2x, and I can add the 3 and the 1 and the 4, and that is h plus s of x. Okay, let's just try a number. Let's say I want to find out what h plus s of 0 is. Well, if I plug 0 and I get 0 plus 2 times 0 plus 4, it ends up just being 4. Now, just to check, like, what if I did this? What is h of 0 plus s of 0? Okay, so if I plug 0 into h, plug it into there, I get 0 plus 3 is 3. Plug 0 into here, 2 times 0, 0 plus 1. And look, I get the same answer. They end up with 4. So when you're asked to evaluate h plus s of a number, you have a choice. You can either combine them first, right? Those are the two functions added together, and then plug in your number, plug in 0, or you could plug 0 in separately and just add the results. Because again, that's really important, is h plus s of x really just means to take h of x plus s of x, okay, and add them together. Okay, now one thing also to notice is if you look back up at these functions, right, h and s, h, right, the domain is all real numbers, right? You can plug anything you want in for x, there's no restrictions. And for 2x plus 1, you can also plug in all real numbers, there's no restrictions. So there's no restrictions on what you can plug in there. Unlike the first one, right? On the first one, I could only plug in what was in the domain, which was 2, 3, and 4, right? We couldn't plug in 1 because it wasn't in F. I could just plug in 2, 3, and 4. Okay, let's take, how about we try one where you have a finite function. By finite, I mean it's just a set of points. There's a limited amount of points. And we're going to combine it with a function that has infinite solutions. Like, so we're going to do f plus h, right? F is those 3 points. H is that equation down there. Okay, so let's try that. So again, in our minds, we just have to know this means f plus h means to take f plus h of x, which means to take f of x plus h of x. Now on this one, right, I can plug anything I want into h. The domain is all real numbers. But if you look up at f, I can only plug in 3 different numbers. I can only plug in 2, 3, and 4. That's it. So remember, you can only plug in numbers that's in the domain of both functions. So I'm only allowed to plug in 2, 3, and 4. So I'm just going to go, what is f of 2 plus h of 2? Sorry, h there. H of 2. Well, see, f of 2, if I plug 2 in, I get 4 back out. See, h of 2, if I plug 2 in here, 2 squared is 4, plus 3 is 7. So I'm going to come off to the side. F plus h of x is equal to these points, right? If I plug 2 in, I got 4 plus 7, which is 11. Whoops. I meant to write those as ordered pairs. Sorry. We're going to have 3 of them. So let's write these as, there we go. Okay, the other, I can also plug 3 in. So if I plug 3 into f, I get 7 back out. Right, plug 3 in, I get 7 back out. Plus, if I plug 3 into here, I get 3 squared is 9, plus 3 is 12. 7 plus 12 is 19. So if I plug in 3, I get 12 plus 7, which is 19. Okay, if I plug in 4, if I plug 4 into f, right there, I get 5 back out. If I plug 4 into here, 4 squared is 16. 16 plus 3 is 19. 19 plus 5 is what, 24? So I plug 4 in, I add them both together. So that is what f plus g of x is equal to. So sometimes they might ask you to do that. A lot of times in your assignment, it'll ask you something like this. You know, just what is f plus h of, 4. It might just ask you to do that. And all you have to do is go, what is f of 4 plus what is h of 4? Right? F of 4 is 5. H of 4 squared is 19. Right? You add them together. Right? If I put 4 in, I get 24 back out. Addition and subtraction and division work the same way. So down below we have some examples of those, and we'll go through some. But it's the same thing. The only difference is instead of taking the two functions and adding them, you can take the two functions and subtract them instead. So let's try that. F minus g down there. And then we'll find out what that equals to. Just erase this and get it out of our way here. So we're going to do f minus g. We'll do subtraction instead of this. So all that means is, again, is to take what f of x is and minus what g of x is. Okay, so let's see. Remember our domain, it has to be the domain has to be the same in both functions. So I can do the 2, the 3, and the 4, because this one has a 2 and a 3 and a 4. I can't do that one because f doesn't have a 1. Okay, so if I plug 2 into f of 2 is 4 minus g of 2 is 3. So when I plug in, so f minus g is these sets of pairs. When I plug in 2, I get 4 minus 3, which is 1. Okay, let's try the next one. Plug 3 in. So if I plug 3 in, so I'm going to plug 3 in. Say I plug 3 into f, I get 7. I plug 3 into g, I get 5. And I'm going to go 7 minus 5. So that comes out to be 2. Okay, and the last one I'm plugging 4 in. Plug 4 in, I get 5. Plug 4 into g, I get 2. 5 minus 2 is 3. So I plugged 4 in. So exactly the same thing we did up above. The only difference in this one, again, is that you are subtracting instead. Let's do this one right here. Let's do h minus s. So in this case, we have two functions that are described by equations. So again, we know that h minus s means h minus s of x, which really means to take h of x minus s of x. So let's start with h of x equals, it's a x squared plus 3 minus what s of x equals. Okay. Now, if I write it like this, I've just made a mistake. So pause the video for just a second, take a look at what I just did and see if you can figure out what my mistake would have been. So hopefully you noticed when I put minus, I have to subtract all of s of x. If I write it this way, I'm only subtracting the 2x when I need to subtract the whole thing. So I end up with x squared plus 3 minus 2x minus 1. Okay, combine them together. We end up getting h minus s is equal to x squared minus 2x, 3 minus 1 plus 2. Okay, and now I can plug any number I want in there. You know, if I ask you to find what is h minus s of 4, well, you know, all I do is plug 4 in here and plug 4 in here. So what's that? 4 squared is 16. 2 times 4 is 8. So 16 minus 8 is 8. 8 plus 2 is 10. And we have my answer. Now, if you wanted to, you know, if I ask you at the very beginning, let's say I just asked you at the very beginning, what is h minus s of 4? You can just go like this. What is h of 4 minus s of 4? And that should give us the same answer we got down here, which is 10. So let's try it. H of 4. If I plug 4 in up here, 4 squared is 16 plus 3 is 19. S of 4, plug 4 in here. 2 times 4 is 8. 8 plus 1 is 9. Hey, 19 minus 9 is still 10. So if they just ask you to evaluate for a number like that, h minus s of 4, you can just go h of 4 minus s of 4, find out what your answer is. Or you could combine the functions together like we did here, and then plug your 4 in, and it should come out to be the exact same thing. Let's do some multiplication here. So you can see some examples of multiplication. The f plus g is just like the other examples you did with the points, except you're going to take, you know, when I plug 2 into 2f, what do I get back out? When I plug 2 into g, what do I get back out? And then you multiply them together. So that's not too different from from what we just did. Let's try h times s and see what it works out to be. Just erasing all this junk up here to get out of the way here. Okay, so let's go down to that h times s. So I'm gonna put it up here, h times s, which just like before, that really means h times s of x. Which really means I'm gonna take what h of x is and times it by what s of x is. That's all it means. I think it makes a lot more sense, this makes a lot more sense when I write it this way. Well, let's see, what is h of x equal to? That's x squared plus 3. What is s of x equal to? That's 2x plus 1. And that's really my answer. Now I can simplify that a bit, right? I could multiply that out. So if I multiplied it out, I'd end up with 2x cubed plus x squared plus 6x plus 3. So that is what h times s of x equals. And sometimes they might just ask you for that. They might ask you just to find this, simplify it, you're done. Now, if they ask you to evaluate for a number, if I ask you to find h times s of 2, okay, now we're going to take the 2 and plug it in there, right? So 2 cubed is 8, times 2 is what, 16, 2 squared is 4, 6 times 2 is 12, plus 3. You'd add that all up, that's what, 20, 32, I think 35. So h times s of 2 equals 35. Now that's if I've already figured out this equation. Now your other option is, if I ask you to find this, your other option is you could just go, what is h of 2 times what is s of 2? Well, see, h of 2, if I plug 2 and 2 squared is 4, plus 3 is 7. S of 2, 2 times 2 is 4, 4 plus 1 is 5. 7 times 5 is 35. So if they ask you to find h of s of x, you've got to just work out the equation, right? Find out what is the equation of the answer. If they ask you to evaluate it for a number, you could do this first and then plug in your number like we did right there, or you could just do them separate. What is h of 2, what is s of 2, and you multiply them together. The only thing we haven't done is division. Just to do one thing, just really quick with division, let's do h over, let's do this one, h divided s, and figure out what it comes out to. Just going to erase this stuff up here. So this is going to be the same thing. One thing to keep in mind is you just have to be careful that you're not going to get a 0 on the bottom of the fraction. So if s is on the bottom, you've got to make sure that you don't get that you're not going to plug something that's going to give you a 0 on the bottom. Okay, so h divided by s of x. Okay, again, it literally means take h of x over s of x. That's it. So we can do that. H of x is x squared plus 3. S of x is 2x plus 1. If you could simplify it, you would. But there's nothing really we can do to simplify that. That's my answer then. That is h divided by s of x. Now, if I ask you to put a number in, we could do like 1. Oops, sorry. Plug in 1 in there, right? So all that means, plug 1 in, I'd get 1 plus 3 is 4. 2 times 1 is 2, plus 1 is 3. I end up with 4/3 right there. Now, by the way, that would be the same thing as up here. I could have just done what is h of 1 divided by s of 1. You get the same answer, right? One thing to keep in mind is if I put, I think if I set that equal to 0 and solve it, I get a -1/2. So x cannot equal a -1/2. So that would be actually not part of our domain. So hopefully that kind of makes sense for combining functions. That's the adding, subtracting, multiplying, dividing. The next thing we're going to talk about is compositions. I think I'm going to do that as a separate video just to make it easier and break it up for you.